Hello and welcome back. So today we'll do discussion on past year on 2019. Let's begin. Question 1, you are given with 3 charged particles, magnitude of charge and the distance are shown in the questions. So what is the magnitude of the resultant force act on Q2? So this is about the electrostatic that you learn about the Coulomb's law. Formula is the QQ divided by 4 pi epsilon naught R square. So I think all the values are shown in the questions. So you just put in the formula. So for example, that we know that Q1 and Q2 will experience attraction force between them, since one of them is negative and another is positive charge. But for this case, we do not need to care about the directions. We just need to calculate the magnitude of the resultant force. So to roughly talk about direction, so it will be towards Q1 and also towards Q3, which is also negative charge that is opposite to the charge of Q2. So resultant force will act in this way, and now we're going to calculate the magnitude using the Coulomb's law. So for the first one is a force between Q1 and Q2. So you just put in the value, like the magnitude of Q1 is 45 nano. And as for Q2 is 32 nano. And then divide by 4 pi epsilon naught. And the distance would be 0.8 meter. Okay, remember to change to meter. So now we're going to calculate the value. So you have 45 nano multiply 32 nano divide by 4 divide by pi divide by epsilon naught, which will be constant of 32, and then divide by 0.8 squared. So you will get 2.02 times 10 to the power of negative 5. Next is about the force between Q2 and Q3. So everything is the same. So except the charge now is changed to Q3, which is negative 56 nano. So do not care about the direction, and the distance would be 0.6 meter. So we're going to recalculate again about the value. So 56 nano multiply 32 nano divided by 4 divided by pi divided by epsilon divided by 0.6 squared. So you will get 4.47 multiply 10 to the power of negative 5. So what are the next steps? So it will be finding the magnitude using the Pythagoras theorem. So Pythagoras will be square root of 2.02 square plus 4.47 square multiply 10 to the power of negative 5. So the answer would be square root of 2.02 square plus 4.47 square. And you will get, you have the answer 4.9 times 10 to the power of negative 5 Newton, which is C. Okay. So we're going to look at question 2. So question 2 is about distance between 2 point charges, positive 2Q and positive 3Q. And the distance is R. So what is the electric potential at the midpoint between the two charges? So it's something like you have the positive 2 and positive 3Q. And the distance between them is R. So we are going to find the electric potential at the middle. So we need to have the formula of electric potential. So if you cannot remember, we quickly do the derivations. So I usually do the derivations to solve the question. So F equal to QE. And we know that electric field strength is V over D. Or we can set as V over R for this case. And from here, we can quickly derive the formula of electric potential where the force multiply R divided by Q. So you have the electric potential FQ over 4 pi epsilon naught R. Okay, so if you need more information about derivations, you can refer back to my video. So now we're going to find the electric potential at the middle due to point Q and point of positive 2Q and positive 3Q. Okay, so we just do some summation on the two forces due to these two charges. So first is by 2Q, so it would be positive 2Q. And the distance will be in the middle, which is 0.5 R. Okay. And then it will be summation that you will have positive 3Q. And the distance is also 0.5 R. Okay. So now we're going to just do the addition. So positive 2Q plus 3Q will be 5Q. Okay, 5Q. And the distance 0.5 R. So you can times 4, you will have 2 R instead. So the answer would be D. Okay, donkey. So going to question 3. So capacitor of capacitance 18 microfarad and a resistor of 1 mega ohm connected to a battery, and initially the switch is connected to P to fully charge the capacitor. So the switch is connected to Q to discharge the capacitor. What is the time taken for the charge in the capacitor to decrease to 37% of the initial value? So the statement is same as the definition of the time constant, which is the time taken for the current drop to 1/E, or it is 37% of the initial value. So if you understand the definition, it is the time constant, which given as the formula of RC. So the question is quite straightforward that you just substitute the formula. Okay, you have the resistance 1 mega ohm. And as for the capacitance is 18 micro. So it's quite straightforward that you don't need the calculator. It is 18 seconds. Okay. So A. So next is question 4, which is a variation of energy stored in the capacitor with a charge Q during the charging process. So we have learned the formula of half CV square, and also you can derive it into half QV and also half Q square over C. Okay. So which formula to be used, you need to carefully observe. So I think the first is not possible since all the four graph is U against Q. Okay, so either this or this, I think you need to understand about the graph that you have 3 types of variables. First is definitely the manipulating variable, responding variable, and lastly is the constant variable. So you need to be sure which is the constant variable in this case. So either V or C would be the answer of this question, the key answer for this question. So usually the capacitor would be selected as the constant variable because it can only be changed by modifying the structure or the design of the capacitor. So for here, the voltage may not be constant. It does not state the statement of the V as constant variable. So we only can safely to assume that C is constant in this case. That this should be U. Okay, that the energy, energy is proportional to the square of Q. So the answer would be A for this question. So next we're going to look at question 5. Okay, so question 5, density of copper is this and relative atomic mass. If the copper wire carries a current with a current density, so what is the drift velocity of the electrons in the wire? So this question is exactly the same as one of the questions I discussed in my previous slide. So you can refer back to the slide for more complete discussion. So for here, I will straight to the point. So we have the I equal to NEF, and the current density would be NVE, okay, where you divide the first equation with area. So now we are given with the density and the relative atomic mass that the formula is given as here. So according to what I discussed, so we need to get the electron density since you are given with the current density, nothing else. Okay, so you need to find the drift velocity and you need the current electron density. So we need to derive the current density based on the density and the relative atomic mass. So based on the discuss, so we just divide these 2 equations. So where we have the density over the molar mass is equal to the number of mole divided by the volume. Okay. So based on the discussion on that day, we have one assumption which is quite important, that every atom is contributing 1 electron. So the statement doesn't state it here, but I think we can assume that every atom contribute 1 electrons. So we can try to solve this question. So multiply both sides with the Avogadro number, since one mole of atom has the Avogadro number of atoms, that every atoms contribute 1 electron. So this is a very important assumption that will be used for this question. So we multiply both sides with the Avogadro number, and we can have the electron density. Okay, so we have the number of mole multiplied the Avogadro number. So that the every atom contribute 1 electron. So it will become the number of electron divided by volume, and it will be the current density. So this is the formula that we use to calculate the electron density. So put in the value that the density of the copper is 8,920. Multiply the Avogadro number divided by the molar mass, 0.0635 kilogram. Okay, you need to change to the SI unit. So we're going to calculate the value. So 8920 multiply the Avogadro number, which is the constant of 24, divided by 0.0635. Okay, so the answer for the value for the electron density would be 8.46 times 10 to the power of 28. Okay, electron per meter cube. So now we're going to find out the value of the drift velocity using the formula of J over VE. Okay, so we have the current density as 1.67 times 10 to the power of 6. Okay, divide by times the electron charge. Okay, so calculate the value again. So 1.67 divided by the answer, divided by the charge of electron, which is the shift constant of 23. And you will get 1.23 times 10 to the power negative 4, which the answer will be B. Okay, B. So next we're going to look at question 6. So two cylindrical resistors are made of copper and aluminum respectively. Cross-sectional area and the electrical conductivity of the copper are 4 times the cross-sectional area and the conductivity of the aluminum. So if the length of both resistors are the same, what is the ratio of the resistance of the aluminum resistor to the resistance of the copper resistor? So we have learned about resistance is equal to rho A over A. That is what we have learned in SPM. And then in Form 6, you learn about the conductivity, which is the reciprocal of the resistivity, which you get sigma L over sigma A. So that's the formula we use to derive the resistance of these two resistors. So let's say the aluminum is Ra. So we will have the length divided by the conductivity of the aluminum and also the area of the wire. Okay, and then as for the copper, so it has almost the same, except it has 4 times the conductivity of aluminum, 4 times the area of the aluminum wire. So here and then we can factorize it, become as 1 over 16 multiply length divided by the sigma and the area. So here you would have 1 over 16 of resistance of aluminum. So here we're going to find out the ratio of the resistance of aluminum resistor to the resistance of copper resistor. So we need to adjust. So here we would get the ratio of resistance of aluminum to the resistance of copper. That would be 16, which is equal to donkey. So question 7 is quite straightforward. So we have learned about internal resistance. So we have the equations of the voltage across the battery is equal to the negative IR plus the voltage plus the potential difference across the battery. So sorry, this should be the EMF, okay? The EMF of the battery. So the if you compare with the equations of y equal to mx plus c, so you should know that the internal resistance can be obtained from the gradient that is equal to the negative of the gradient. As for the y-intercept, it should be the EMF value, and the others are not much useful informations. So we continue with question 8. So we have 3 identical dry cells, each with 1.5 volt internal resistance of 0.9 ohm. So the combination of dry cells is equivalent to 1 dry cell of EMF and internal resistance R. So what are the values of EMF and the internal resistance? So you just need to convert these 3 dry cells into 1 equivalent dry cells. So first is the voltage. So we have these 3 of them are 1.5. I think based on what we have learned, so parallel should have the same potential difference, and in series you just add them both. So you would have 3 watt for the EMF. And as for the resistance, so just apply what you have learned. So this is the internal resistance, internal resistance, internal resistance. So each 0.9, 0.9, 0.9. So parallel of these 2 resistors would give us half of the value, which is 0.45. Okay, you should understand what I mean. And then you add with 0.9, that will be equal to 1.35 ohm. So answer is B. Next is question 9. Which condition does not produce magnetic field? So quite a straightforward. Moving charge, yes. Moving bar magnet, even the stationary also can produce the magnetic field by the bar magnet, and also the electric current, yes. And except the constant electric field does not produce magnetic field. Next, question 10. So when a point charge with a magnetic Q moves with a velocity v in the magnetic field, the magnetic force acts on the charge. So which diagram shows the correct orientation of force relative to the B and V? So this one is you need to use Fleming left-hand rule. So I think you need to practice yourself. So bear in mind that you have positive charge here, positive charge, negative charge, negative charge. So for A and B, you just use your left hand as usual. But for C and D, you need to remember to reverse the direction of the force. Okay, so let's see question A. So you do it yourself. So it will be, okay, it will be outward force for this case. Okay, and for B, okay, so it should be to the right. Okay, so I hope I'm not wrong. So question C, I think it should be, okay, so if you do it normally, the direction is downward, but since this is an electron, you need to reverse to the top, okay? And as for D, I think this should be the answer. So yeah, okay, so remember you need to reverse the direction. It was downward, but since it's electron, so it goes upwards. So the answer is donkey. So if you don't reverse the direction, you will get answer as C, which is wrong. Okay, you need to remember electron, you need to reverse the direction of the force. Okay, next question 11. So conducting plate of thickness placed perpendicularly to a magnetic field, what is the whole voltage generated when the current flow through the conductor if there are 8 times 10 to the power 28 electrons per meter? So this is the electron density. So the whole voltage is, you have learned before. So if you don't remember the formula, you need to understand how to derive. As for me, I don't memorize. So let's do the derivations. So I remember that you need to achieve one condition. I mean that they will achieve a condition that the electrostatic force will be balanced by the magnetic force produced in the wire. Okay. And as for the electric field strength, it can be expressed as a V over D, and it is continue on, you would get the whole voltage as dVB. Okay, so this is the first equation we can get. Okay, so if you don't remember, please watch back my video and practice more on the derivations. So next, we're going to use another formula from the current, which is I is equal to NEF. Okay, so we have the velocity, drift velocity formula, which is I over NAE. Okay, so we substitute V, drift velocity, into the formula of whole voltage, and you will have dB multiply I over NAE. Okay, so this is a quick one. So you need to practice until you can derive in maybe less than 30 seconds. Okay, that will be the best because you need to be fast. Okay, so here you have IB. So I know that D over A is T. So IB over net. So we have the current. Yes, I think we have the current. Current, density, magnetic field strength, electron density, thickness, and also the charge of electron. So everything is okay. So we can find the whole voltage. So current is 3.4 multiply the magnetic field strength 1.2 Tesla divided by the electron density. And then the charge of electron, and then also the thickness. So you need to change to SI unit. Okay, so I think quite straightforward. So V is equal to, so 3.4 multiply 1.2 divided by 8 divided by electron charge, which is 23, divided by 0.5 milli. And you would have 6.36. Okay, -7. So yeah, okay, answer is B, 0.64 microvolt. Okay, next question 12. Current in a coil decreased uniformly from 3.6 to 1.4 ampere in 0.25 seconds. So this would give you the rate of change of current. And what is the EMF induced in the coil if the inductance of the coil is 4.4 millihenry? So straightforward. So we have negative L di dt. So negative signs is just to fulfill the Lenz's law. So if you only consider the magnitude, I think you can straight away to calculate, but I would consider in this case. So 4.4 milli multiply the rate of change of current where you have 3.6 to 1.4. So final minus initial value divided by 0.25 seconds. So let's try. So 4.4 milli divided by 2.2. Sorry, times 2.2 by 0.25. So you would have 0.038. So which one? I think -2. Yeah, okay, answer is B. Okay, 3.9 times 10 to the power -2 watt. So next, we look at question 13. So wow, okay, plane of circular coil entrance with area A is placed at an angle theta in a uniform magnetic field as shown in the diagram. So what is the magnetic flux linkage? So yeah, we have learned about NBA cos theta, but look carefully, the angle is between the magnetic field and not the correct position, okay? So we need the vertical components, okay, that is penetrate through the coil. So if you look at trigonometry, it should be NBA sine theta, okay? You need to be careful with the questions. So next question 14, you have a resistor connected in series with an AC source. Okay, which is not true about the circuit. So let's see. So we have this source and the resistor. Maximum current of the circuit is 0.625 ampere. So we can try to calculate. We have the peak voltage 250 divided by the resistor 200 ohm. So it will be 1.25 ampere, which is wrong. Okay, it should be 1.25 ampere. Root mean square of current. So let's calculate it. Will divide by SERT2. We have learned it. So it will be 0.88 ampere, correct? Maximum output voltage, okay, this equivalent to the word peak voltage, okay, it should be 250, which is also wrong, okay, this question is, there's bug here, okay, so maximum output power, so power equal to VI, okay, so peak current multiply peak voltage. So you have 312.5, yeah, okay, 313. So for this question, it has two answers, A and C. Okay, last question, question 15. Pure inductor of self-inductance 0.12 Henry and a pure resistor connected in series with a sinusoidal voltage source of frequency 50 Hertz. So what is the root mean square of current in the circuit if the root mean square of voltage is 230 volt? So quite simple, V equal to IZ. So we need to have the impedance, and before that we need to calculate the reactance of the inductor, where you have the formula of omega L, okay, hope you remember that, or you have 2 pi FL. Okay, so since you're only given with the frequency, not the angular frequency, okay, you need to be sure the difference between omega and F. So now we're going to calculate the reactance. So XL is equal to 2 pi multiply 50 multiply the inductance is 0.12. It would be 12 pi, okay, 12 pi ohm. Okay, as for impedance, okay, so square root of R square 40 ohm plus 12 pi ohm, 12 pi square, sorry. Okay, so 12 pi square plus 40 square root. So you have 54, about 55 ohm. Okay, so to find the current, ratio of voltage to the impedance. So you have 230 as root mean square, so you don't need to convert, divided by impedance. Okay, so continue. And you would have 4.18, which is 4.2 ampere C. Okay, so that's all for section A, 2019 past year paper. So I will continue for section B and C in another video. So hope to see you again. Thank you for listening.